let's give this another 30 seconds or a minute, and then we can get started. All right. Hi, all. Welcome to this month's edition of the CCC Kernel-SIG. The main topic for today is discussing a spec from the folks at Linaro. So I will hand off to them in just a moment. So first, though, I'll link in the chat to the actual underlying draft spec. And yeah, I'll hand off to the two of you.
Hello, and just gonna put into the chat as well, because I think that the version that we have there is 02, and we have bumped it up to 03. I think it was last week.
Oh, nice. Okay.
Yeah, just a few changes. As whenever we do change things, we don't linger. Otherwise, we forget. So we need something to change. We publish it. We just publish it. Okay, so this is a presentation of joint work between Thomas and myself. I'm going to share my screen. Let's see if technology will allow me to do that. There. How does that look to you? And if I do slideshow, does that help? That works fantastic. Okay. So this is, as I said, joint work between Thomas and myself. It aims to formally represent claims that are coming from devices that are compliant with the SPDM and TDISP standard. So first we'll go through some introduction material. After that, we'll jump into the thick of it and we'll present the profile itself. Following will be a short example on how this can fit into a bigger picture. And that bigger picture here will concentrate on ARM because this is what we are working with. But the hope is that people will also be able to use this in their own use case and their own platform token, regardless of architecture. Following, we'll present some of the remaining work. And after that, and what I hope will be the bulk of this presentation, open question and a discussion on this specification, what people think of it, what needs to be adjusted, if anything, and hopefully that you'll be able to use it for your needs on your side. So first, some details. This specification is quite short. It's 7 small CDDL files. If you are not familiar with CDDL, it's quite simple. There's a link there. Just click on it. I will share my slides afterwards. 20 minutes in that little CDDL specification should give you all of the required knowledge needed to understand what we have done with regards to representation of the token. Our code is on GitHub. Everything is public. This is where we keep our issues. So if you would like to participate, have fixes to submit, or just file an issue that you want us to look at, this is where it would happen. And obviously as well, everything's on the IETF data tracker website for the official specification. Okay, so just some goals and motivations to start with. As I said before, the idea here is to formalize representation or claims coming from devices. And the idea is that those claims will be the same regardless of the architecture, x86-based, ARM, or RISC. If you have a device that talks SPDM and TDISP, the claims will be the same. And there's also a need for a third-party consumption of those claims. So the idea is to make sure that we don't reinvent the wheel with every architecture, and we kind of make things easy for ourselves. So the goal is to represent the information that is yielded by SPDM, nothing more, meaning that we don't want to extrapolate information from that. And nothing less, meaning that we want to use everything that SPDM gives us. Our target scenarios right now are CMA and confidential computing. CMA, that would be component measurement and authentication, that is part of the PCIe specification. And confidential computing, the workflow for that is a little more convoluted, but hopefully that this can be sorted out with the community as we move forward in the coming months. And last but not least, Linaro has absolutely no commercial gain with this specification, none whatsoever. The only thing we want is to make things easier for ourselves. So before we jump to the thick of it, any questions so far?
Yeah, I have a small question. You mentioned TDISP in your slides here, but I read the spec and there's only SPDM measurements being captured. Are you not gonna also represent the TDISP report in the attestation token?
So that's a question that I have for you guys. So I have not represented TDISP in the current specification simply because it would represent probably a fair amount of work. And right now, there hasn't been anyone coming forward saying, we need the information represented by or contained in the interface report, which is probably the one that would be the most appropriate for verifier consumption. But the information conveyed by the interface report is so close to the hardware that right now, like I said, no one has come forward to say, hey, we need this. It's more of a lead attester, probably, or something that a tester would be concerned with rather than a verifier that is aggregating endorsement and making decisions based on policies. But we're definitely open to do work in that direction should there someone that comes forward and say, hey, we absolutely need this. Okay, so let's get into the specification itself. So the idea here is that regardless of the amount of devices that you have on your platform that needs to be attested, we want to gather all of this under a simple in one single area, which is the device attestation token. It starts with a tag. Right now, it's a Linaro-based tag, but as we move forward with the standardization of this specification, this will be changed to something that is generic and non-Linaro specific. After that, comes a nonce. So this can be used in very many ways. It is simply there for people to embed in their own scenario. And after that, we have the submodules that represents the entity attestation tokens themselves. It starts with the device name followed by the claim sets. Right now, the claim sets that we have are SPDM claims and PCIe legacy claims. There is, people have asked about CXL claims, CHI claims. We haven't seen a need for that yet, therefore they are not specified. But if there's a need for that in the future, we will certainly get to it. But right now, that hasn't come to the fore yet. So if we look at what those SPDM claims and PCIe legacy claims would be, let's start with the PCIe first and foremost. It's the most boring one. And it is there simply because right now in data centers, people will have assets, will have hardware that is still usable, and they want to maximize the lifespan of that. So it becomes a question of policy as to whether a consumer wants to use a confidential VM that would have a legacy device. Should there be a case for that, and should people want to move forward with this, the only thing that I thought was usable was the PCIe type 0 and type 1 config space. and in there, the vendor ID, the device ID, and anything else that people might find useful, but those will not be mandatory. A lot more interesting is the SPDM claims itself. Again, it starts with a token, the SPDM artifacts, and the VCA. The VCA, which is version, capability, and algorithm. So this is the triple that starts a communication with an SPDM compliant device. This was put there for debugging purposes. If people want, or if people think that there's useful information in there for them to use, fantastic, by all means. It is there. Use it if it suits your scenario. The SPDM artifacts can be, depending on again, the use case, it can be the measurements themselves, it can be the certificates, or both the measurements and the certificates. Here we are able to handle all three cases. If we look at what those are about, the certificates themselves, this is probably the easiest to start with. SPDM gives us 8 slots to work with. Slot 0 is the default certificate slot. Slot 1 to 7 are not mandatory. And in there, we simply do not discriminate about what kind of certificate will be populated by a vendor. The specification will define 3 types of certificate model: device, alias, and generic. And once again, there's no point in making any discrimination here. You can use whatever suits your use case.
So I'm just going to note for a second, there are a few comments inside of the chat itself so far. So I want to give
okay.
a chance. I don't know if
I'm not able to read the slides and read the
yeah.
The
so
chat.
that's what I was guessing. That's why I was going to give people a chance to chime in if they had their questions.
So let's stop here and take questions if there's So do people want to ask their questions live, or should I read the chat?
No, I can ask a question live. I was wondering why the PCIe data is fully broken out, but the SPDM data isn't. It would strike me that most of our tools use the binary representations of PCIe data, not the CDDL ones. So having the binary representation would probably be the better form.
Binary data for SPDM, you said?
No, you already have that. I mean, the binary data for the PCIe config space. You have it fully broken. Well, you have it broken out into certain fields you like, and all the rest of the fields get ignored. But why not just store the binary data that we can just feed directly into all of our PCI tools? Because that's what they process today anyway.
Okay, that's the kind of feedback I'm looking for. So that would still be the config space, but you want to see it as a raw bit stream rather than laid out like this in plain text.
Yeah, but you have to understand my position. I mean, given that all our tools already speak the binary, I don't see much value in CDDL. So I'm just annoyed at having to take all the CDDL, convert it back to binary, and feed it into the tool.
Oh, that's a perfectly valid argument. Thank you for bringing this forward. I will fix it.
So you want the raw config space header or what?
Well, yeah, it seems reasonable. The tools know how to program it. It means that we're always extension proof because PCI config space extensions can change this. And if you keep it like this, every time the spec changes, you're going to have to change the CDDL description, which doesn't seem like a good idea given that it adds no benefit.
So my view is that you don't need all of the information in the config space because there is a portion of the config space is actually signed and is part of the as part of the subject alternative name. And so my view is that you only need the information that's actually signed. So that's the vendor ID, device ID, revision ID. I don't know, I think the revision, I'm not sure if that is actually part of the subject alternative name. The class code is, but for example, command and status registers are not part of the subject alternative name. So my view is I would just omit that.
But unsigned data still adds interesting background value, even if you can't trust it. And also, if you omit some of the stuff, some of our tools get annoyed that it's missing. even if it's not signed. I mean, we can just make it up, but again, what is the point of constructing a format that's different from something that's already standardized?
Yeah, I mean, the information in the config space is only relevant for this particular use case insofar as it's used to identify the device, and like command and status registers don't identify the particular device. It's just in particular, this is mutable. This can change all the time. So I don't know if this is useful. I mean, maybe, for example, it gives you the information whether the memory whether memory access to the device is currently enabled or not. So I don't know, maybe that's useful, but I'm not sure, to be honest.
Okay, I know definitely from the people looking at this from debugging purposes, they're going to ask for this. It could be nobody else cares about it, but since the amount of data is so small, it doesn't really matter, does it? You might as well store it anyway.
Yeah, so I think LSPCI is probably the only tool that actually parses the raw data. I'm not aware of any other tool that parses the raw config space header. So my view is that any dissecting this and presenting it as vendor ID, device ID as separate, only the relevant portions of the config space, that would, in my view, be sufficient, or just my 2 cents worth.
James, were there other tools besides LSPCI?
I think there are, but LSPCI is the only one I use as well. It's the only one most developers use. It's the most useful one. DMI decode does some of this as well, doesn't it?
One option is to basically extend what we have there to include the CDDL presentation, but also make them configurable or make them malleable based on the use case that we have. So either CDDL or raw binary. But would that work for you?
So to be sure, including the vendor ID and device ID and class code and stuff like that from config space does make sense, because you want to compare that to the subject alternative name, because it gives you a direct information whether the device is trying to fake that information in config space.
Would you leave the command and status registers in there?
Personally, I wouldn't.
You would not. Okay.
I mean, mostly it sounds like the goal is like, or the question is, do you want to have additional information for debugging, or do you want to only have validatable, verifiable information inside of this? Sort of a norms question for what the goal of this is. And because if we only want verifiable information, then it might be worth the pain of not being able to directly interact with existing tools. If we're doing this for debugging, I think we definitely want to do so.
Well, if you look at our other security systems, let's take the TPMs and TCG logs. They have a load of entries in their logs that are not verifiable in any form. They're just there specifically to provide information, but the information can't be trusted. There's no reason why you have to have only trustable information in the log.
Okay. All right, so let's continue with the more interesting part, which is the SPDM claim itself. So like I said, we talked about the artifact, we talked about the VCA, which is there for debugging. So the point that you're making there, James, is completely valid for legacy devices as well. So there's, we can certainly do that as well. So let's look at the certificate itself. We talked about that. Let's look at the measurements. So SPDM standard gives us 239 block IDs. So with every block ID, you have a measurement. And here, and this part is a little important. I have chosen to add a signature that is optional, just like the specification describes. but here the signature covers all of the block ID rather than one block ID per signature. If there's a use case for one signature per block ID, we can do it, but I just wrote it like that because it is likely that people are simply going to issue a set of measurement requests and then on the last one ask for a signature on the whole block. Again, this is up for debate. This is just a draft, and we're here to gather comments. So if we're looking at, go ahead.
Question about your encoding now. If you're going to use ASN1 anyway, why do we have to have two different types of encoding? Why not just use ASN1 for everything?
So you're going back to the certificates there, right?
Well, if you're keeping the certificates in ASN1, why are we doing CDDL? Why not just use ASN1 for everything? Since it's actually a more flexible language than JSON, it's just got a much more annoying binary representation. But if we have to deal with the annoying binary representation anyway, it is actually a much better binary language.
Thomas, what's your take on this here, since you're the verifiers?
Yes, exactly. On the verifier side, we're trying to converge on CBOR as an universal encoding. These certificates here are supposed to be dispatched to a library that can deal with X509 stuff, and you have you encapsulate those as they are. The transport doesn't care about what's there. As soon as they eat the verifier will pop up the thing and call the library for verification, right? So set up the path construction and validation and run the thing externally, right? I think this is really a matter of converging on what the RATS architecture sort of tries to push in terms of the data layer encoding, which is CBOR. That's basically the choice we're making here to make it homogeneous across the remote attestation interfaces, which are not just attested to verifier, it's also supply chain to verifier, it's also verifier to relying parties. So if we can, minimize the number of encoder decoders that we need, that would be ideal. And this is a step in that direction.
I'm biased. I think CBOR is the worst binary representation you can have. I'm fine with JSON, even though it doesn't have representations for a lot of stuff, just because it's very easy to do. But if you're going to do a binary representation, ASN1 is definitely better than CBOR. I mean, if you have to deal with annoying binary representations, they're both as annoying and difficult to parse. Well, actually, ASN1 is slightly more annoying and difficult to parse, but I mean, pure JSON is sort of much easier for humans to read.
True. But yeah, these are choices that are made at at the IETF
it's
level.
A standards choice. I get it. It's just annoying.
I agree.
All right, let's look at what those measurements look like. So for every measurement, we have a component types. Right now, there's 11 of those, and those are basically set out in the specification. It gives you, each component type gives you an idea of what you're looking at. Also, according to the specification, the measurements can be either raw bitstream or a digest, and that digest would be from the algorithm that was chosen at the VCA exchange. And last but not least, the most complex part is the signature block itself. Starts with a slot, so that's the slot that would include the certificate that holds the key pair that will have signed this the measurement block, and their certificate will include the public key, allowing you to verify that signature. We have a requester nonce, responder nonce, again, that we are follow what is in the specification. The combined SPDM prefix here, there's no point in going into details. It is quite well explained in the SPDM specification. It is concatenated with a hash of the L1 message, and that L1 message is the VCA. All of your measurement requests respond along with the last one, which is a get measurement, get response that will have been signed. That is all hashed and signed and included in the token as we have here. So all of this information here is presented so that a verifier can recompute the signature and verify that it matches what the device has come up with. I expect that there will be questions on this part. And I'm quite surprised by the fact that there isn't. Okay, if we're looking at how this fits into a bigger picture, the left-hand box is presenting, again, this is an ARM example. So we have your platform token or your CCA token, which includes your realm token and your platform code token. The platform describes what the architecture is, what the hardware that you're running on is, and the realm token is a description of the configuration of the secure virtual machine that is currently running. There's a nonce in there. That nonce is the same as the one that we find in the left or the right-hand box, which is our entity attestation token with our measurements and our certificates. So if we have the same nonce in those two entities, we simply wrap that into a CWM that is then signed by the lead attester, and that is how we make the link between the two entities. Now, there are other ways to use the entity attestation token into a broader design. This is simply a very simple example to show that, yes, it is possible to link the two together, sign, and send that to a verifier. If we're looking at the remaining work that we have, I would really like to expand this to the SPDM challenge request response. This is to cater to pure CMA scenarios. That would mean that the measurement block will become a lot more generic simply because the signature of an SPDM challenge and the signature of measurements is similar. As I talked earlier, there's new bus technologies that are coming on the horizon, whether that's CXL, CHI, or anything else. I don't have a crystal ball, but the idea is to be able to accommodate those as they come forward. And the idea also is to document how we intend on ARM to link the CCA token and the device assignment token so that they are cryptographically linked together. We want to add that description for ARM, and the idea is that hopefully that will encourage other people, other architecture to do how they, or to write, describe how they would proceed on their for their use case. So now the questions that we have. So how to keep with upcoming SPDM versions? That is something that is that hasn't been sorted out yet. We talked about it, but we don't have a precise plan of attack for that. Like we talked earlier, do we need to describe TDIS artifacts? The only one that I see being the most useful would be the interface report. But again, that is so close to the hardware that I don't know if it's consumable or usable by a policy and a verifier. And last but not least, can you use the specification? And if no, what needs to change? So this is what I had for you today. I feel like I've talked enough. I'd like to give the opportunity to other people to voice their opinion and their comments on this.
So just on one, we have exactly the same problem in the UEFI Secure Boot, well, the UEFI specification. Secure Boot relies on a whole load of stuff which is forever changing, and the advent of post-quantum cryptography just really emphasized that. So if you depend on a spec that's highly variable, the trick is to import it in such a way that all the variations are handled in the spec. So you just refer to it in your spec. You don't try and reparameterize it. That's what we actually did in UEFI Secure Boot. We have all of these hash defines for pretty much all of the GUID ciphers, whatever. And the thought of actually just having to rev them every time they come out with a new post-quantum algorithm sent us all into a tailspin. And we decided what we'd actually do is just refer to all of the defines in the Authenticode specification, and then Authenticode could look after it, and we didn't have to.
I have kind of the same strategy in my head. I just haven't come to the point where I have to put it into CDDL and be able to this and provide this kind of flexibility. But I'm happy that I'm not out to lunch, that other people have done kind of the same thing.
Well, no, it's the last one everybody thinks of. That's why the UEFI spec looks the way it does. It's just that you always reach a point where you think, oh my God, why didn't we do it this way?
Oh, we will. I agree with you. I'm very cognizant of that fact. At one point, there will be a reckoning, and we'll ask that exact same question: what on earth happened? But right now, that's always the crystal ball conundrum. Right now, we deal with the information that we have in front of us.
Have you included, so in the SPDM, I think 1.4 spec, they added support for PQC, and that has indeed complicated the specification massively. Have you already looked at the spec, and is that already included in this presentation or in your current CDDL spec?
So the bulk of this specification was written on 1.39. I've looked at 1.4, but I haven't looked at the algorithms that are supported. If there's changes there, that will be the first time that we have to accommodate a new representation.
Right. Yeah. So the problem is that the signatures become extremely large, and because all the certificates in the certificate chain are signed by the previous certificate, the certificate chains also become extremely large, and the up until 1.3, SPDM 1.3, the maximum size of a slot is 64K. So you can store a larger certificate chain in the slot, but that's not sufficient for these larger PQC signatures. And so they invented a new scheme. So they basically have a parallel infrastructure for these larger slots. And it has complicated the specification quite a bit.
Right. I think that's why we did not put a specific size on our our certificate chain.
Yeah, good on you.
Specifically for that, because it dawned on me that this would be fluid. Now, if there's more measurements to take into account, what you're telling me is to go back and look at the measurement section in SPDM 1.4, something that I will do.
And then on your last slide, this open question about TDISP. So I'm wondering, can't you? So I think this device interface report, isn't that kind of a superset of what you're doing, so that you can basically create a specification for that device interface report, which has what you currently have, like as one element? Does that make sense?
I'm not sure to understand.
So the device interface report includes, for example, the I think it is retrieving all the measurements in one go and they're also signed. So I guess that is like one element that you already have defined here. And so I think the device interface report will just be a superset of what you already have.
The device and the
That's
TDIS
not true, because SPDM
Right.
measurements are separate from the TDIS device interface report.
Right.
The TDIS
So-
device interface report has things like MMIO ranges,
Right.
some vendor-specific fields, control data, things like that. So this is essentially, I think, after listening to your presentation and thinking about my initial question, I think it'd probably be better just to have a separate attestation token for the TDIS report and then bind them together with the conceptual message wrapper.
Bind them together.
Yeah. Because you also have to realize the SPDM measurements are a host side device idea where the TDIS report is specific to a given TDI, right? So they're related, but they're not necessarily that SPDM measurement essentially might get shared across multiple TDI attestations, because the host may only pull that SPDM measurement once and just reuse it cached for a while, right, until it invalidates it.
I have personally not found an answer to the TDIS interface report yet. That's why it's not there.
Wait, but if the host caches the SPDM measurements, what prevents replay? As in, I thought the relying party was supposed to be able to supply a nonce, which would be once per virtual machine.
Yeah, but the reality is the TSM can keep those measurements internally and just sign an SPDM response with the nods, right?
Yeah, that becomes architecture specific, how things with different architecture. On ARM, that's not how it works, but I can see this being the case on other architecture.
Yeah.
But it then sounds like for a confidential VM, internally, all you really have are the TDISP artifacts. You could break out the SPDM ones from them, but you're basically trusting them based on the TDISP report. It sounds like for the guest, the TDISP report is the more pressing one. It's what the guest relies on.
Well, in reality, the guest relies on both, right? Because what it gets out of the SPDM measurements is whether or not it can trust any firmware that was loaded onto the device, right? And pretty much every device that we've been talking about that I've seen in discussions has at least one driver-loaded firmware. So there's no way for you to get that out of, say, a DICE certificate chain. You have to pull those from SPDM, and it depends on whatever driver firmware was loaded at the time. And we've had discussions to say, well, if you can validate the particular CVM that was loaded up, then you know what version of the driver and firmware was put into that CVM image. And, by association, you could validate that you're going to trust the driver firmware because you validated the CVM image. But I don't particularly buy that, because nothing would stop the CVM from reaching out to the internet and grabbing a different firmware and putting it on the device. So you kind of have to take into account all these driver loaded firmwares, which is important because the reality is there's really two relying parties here, right? The first relying party in TDISP is the CVM itself to decide whether or not it trusts what the host did with the device. And then the second relying party after that is someone who's going to give you a workload. So they will probably care more about the combined state of both driver and CVM than just the CVM will, right?
Yeah, I think so.
Okay, so this is what I had today. I will stop sharing my screen.
So I have a question, because I implemented this multicasting of received signatures from the kernel to user space if the kernel is doing the PCI device authentication. And what I'm doing is basically I am sending a netlink message, and it includes separate attributes for like the slot number, the hash algorithm, and so these are basically all the same attributes that you're also including in your specification. So it's the idea that a user space application will listen to those multicast messages from Netlink and then encode this in your specification? Or is
Yes.
the idea, or is the idea that the kernel already creates that encoding and okay.
No, I don't think it belongs in the kernel. It belongs. I think it requires the flexibility to belong in user space.
Okay.
Thank you for that work. By the way.
Okay. Yeah. So for example, I chose the approach that I'm not including the signature as a separate entity, as a separate attribute. So I'm just including an attribute which contains the offset in the transcript. So when you need the signature, you go to the transcript attribute, and then you just take the signature from the transcript at that offset. So I'm not, does that make sense? So I'm not including the signature itself as an attribute, just including the offset, because that's smaller. It takes less space, obviously, in the netlink message. But I guess that would not be a problem for the application that creates the encoding that you've come up with, right?
Correct. I see
Okay.
this as, and this is probably why, this is another reason why I think it belongs in user space, because it requires
Right.
this flexibility, and it doesn't have those space issues, memory space issues
Right.
that kernel or anyone else that provides something like this to user space.
Okay. Okay. Thanks for the confirmation.
Are you aware of the RATSD work that's being done at Lenovo?
Are you
Yes.
talking to me?
Yeah.
I guess both our presenters and you, Lucas.
Yeah. Oh, Matthew, go first, maybe.
I did not get the last part of the question. Would you mind repeating, please?
So I believe it was a group of people from Lenovo are working on a user space attestation agent that might solve one of the problems you have in your opens. It's called RATSD. It's out of the Verison project.
Yeah.
And the idea is it has plugins for pulling all the different various types of attestation that will come from the platform, whether it be your CCA CVM attestation or a TD report from TDX. Those are the support that I believe they have at the moment, but they intend on extending it to include NPU and GPU and other accelerator measurements as well. They have that on their future to-do list. The only thing is we don't have a Linux interface currently for them to use for it, so there's no way for them to make that plugin yet. But they presented at the attestation SIG, I think it was 2 or 3 meetings ago, I forget. And it has, the concept of doing the platform binding of the tokens together. It'll pass the nonce down for the attestation to every single plugin. So you'll get the same nonce that's going both to your CVM attestation token, to your each device attestation token you want, and everything like that. And that might be that definitely sounds like a good place to take a raw SPDM measurement and turn it into your token, and then potentially hopefully solve your problem of how do you bind them together. But then you have a larger question: where do you get that attestation key from? Do you have any sort of quoting enclave or whatnot on the platform that you can use for that binding of everything together? But that's a completely different topic for another day.
Yeah, David, I am one of the maintainers of RASD. So yeah, we are aware of that, and
Okay.
there was thank you very much for making the bridge, because that's exactly the way we'd like to go.
Okay.
And in fact, Mathieu's slide, the binding slide with the config FSDSM and the device token is taken from the RASD architecture.
Yeah.
And the binding is done by fan out of the nonces coming from the relying party to all the tokens, and then signing over the aggregate using a key that is attested as a bootstrap step, right? So where RATSD gets measured and then does an attested CSR communication with an outside CA that verifies the evidence and issues the credentials that then is used to sign the aggregate, the CMW.
That makes sense.
So I think we're getting towards the end of questions so far. So one I have, though, is I know you mentioned, Matthew, that there were parts you were expecting feedback for, and there weren't a lot of questions at the time. Could you after this either write things down or enumerate things that you're kind of expecting some amount of feedback on, so that people here can try to help you find people to give you feedback on these portions? Because I'm expecting that if you have questions, if you're in the weeds and you have unanswered questions, we should probably try to find people for you to work with you to try to answer these questions or give you feedback, because we might not necessarily have it. There's only 8 of us here, so that might be a wise thing to do as a follow-up.
And I should send. How do I proceed? Who do I send that email with questions to? You, and then you do the.
No, I mean, I would just say one thing would be like, hey, if I sent out a message to the Linux Cocoa mailing list that was like, hey, here's the spec that was proposed, or here was if you followed up with slides and hey, here are some open questions that I have afterwards. I can try to pull people from Google. I'm sure other people here can probably pull people that they're aware of, and we can try to get you feedback for those portions as well. Or if you sent a message on the Linux Cocoa mailing list, that'd be a reasonable follow-up as well.
Because I did send a message to the Linux Cocoa mailing list a couple of months back. How should I reply to that saying, hey, I presented this and some of the question I still have regarding this, and that, I'm looking for feedback on this.
I think either of those would work, but now that I have, because I read through after you sent it out originally, but mostly I can probably try to pull people from Google at least that are more involved in attestation. But I would also like to push other people here if there's people from other companies to try to grab other folks to try to give feedback as well. Because it seems like a thing that we would want to coalesce onto the point where we can actually either move on. I don't know. This makes sense, but it seems like we should try to close on these things. So
again, should I send?
Either a reply to your email or just a separate follow-up email being like, hey, I presented at the CCC Kernel-SIG. Here are the slides. Here are some common things we talked about. Here are some open questions that I would like to
okay, I will take that option and simply reference the first, give a link to the first. So that's probably a good way to proceed. I like that suggestion. I also want to tell people that I will be presenting this at Linux Plumbers, so that will broaden the audience and bring in more people. And I will also be talking about the work that Lucas is doing and how do we, the user between the kernel and the user space, or the interface between the kernel and the user space. How do we go about doing this and share that between CMA and confidential computing so that we don't reinvent the wheel for these two? So these are the two things that we'll be talking about at Plumbers. If people want to join into this, fantastic. There's definitely room for more people.
Yeah, so I will only be able to join remotely, unfortunately. Travel restrictions.
I will be in touch with you, Lucas, probably around November timeframe to talk about your patch set if you haven't released it yet.
Sure.
Cool. All right. Thank you all for coming, and thank you for presenting. This was a very, very good presentation, and thank you again.
Thank you very much, guys.
Yes, guys.
Bye.
Thank you. Thank you.
Thanks. Bye, everybody.